we have talked about the making triple bonds containing molecules. One way is starting with a simple molecule with a triple bond. The smallest one is acetylene, right? Because the two carbons is the smallest number of the carbon can have triple bonds. And then acetylene, that hydrogen bond to the sp carbons are somewhat acidic. If you're using strong base, we've got a strong base. If you're using strong base like the sodium amide, then you'll be able to take these protons out. That makes a carbon of the triple bond negatively charged. That is a very good nucleophile. At the same time, it's also very good base too. But if it acts as a nucleophile when you're using, sterically non-hindered alkyl halide, like a primary alkyl halide, marginally secondary alkyl halide, then you'll be able to make an SN2 reactions. So that is a way to build parts on the triple bond, so you can grow the molecules with the triple bonds. Acetylene can have two hydrogens on both ends of the triple bonds. So we can do one by one. After you do the substitution on the one side, you can take the protons away on the other side by the same way, using strong base. That makes an acetylene anion. That makes an attack to the alkyl halide. But I want you to be aware of, we can also make an attack to the carbonyl. Carbonyl of the ketones, carbonyls of the aldehyde can be attacked by this acetylene nucleophile. When they make an attack, it makes an attack to the carbonyl carbon that pushes the pi bonds to the oxygens. So you get the oxygen anion, which will be protonated at the very end of the reactions. So you get an alcohol. So alcohol having a triple bond, that is kind of the things that showed it could be probably made this way. So I want you to recognize these possibilities when you're making a triple bonds. But this is basically using a small triple bond and then making a big one. If you want to really create the triple bonds, then you can do double elimination reactions that you need two halides, because with not only once, you have to do twice eliminations. And then the base is needed, but it's got to be strong base. First eliminations are E2 elimination, which can be done in a regular base, but the second elimination is not simple. So that's why you got to use strong base like a molten KOH or the sodium amide, but that got to be heat up to high temperatures. That way, with double eliminations, you can create triple bonds. So those are the two different ways of the making triple bond containing organic molecules.